Every single picture an artificial intelligence has ever painted began as the same thing. A screen of pure, meaningless, random static. No sketch, no outline, no first brushstroke. Just noise, the visual equivalent of a television with no signal at all. Out of that chaos, in a few seconds, emerges a photograph of a place that has never existed anywhere on Earth. The machine is not painting in any human sense. It is doing something stranger. It is running destruction backwards. Michelangelo supposedly said the statue was already inside the marble. He only removed everything that was not the statue. AI image generators work on exactly that logic. The picture is hiding inside the noise. The model chips the noise away. And once you can pull one image out of chaos, you can pull 60 per second, an entire film from static. But that leap from one still picture to living motion very nearly broke the entire method. We will get to that. First, the core trick. It was borrowed not from art, but from physics, from the way cream dissolves into coffee. Because to understand how a machine learns to build an image, you first have to watch it destroy one, on purpose. In 2015, researchers borrowed an idea from thermodynamics. Structure dissolves into disorder in small, predictable steps, like diffusion. Take a photograph. Add a whisper of random noise, then a little more, then more. Step after step after step. After 1,000 tiny steps, nothing remains. The photo has completely dissolved into pure static. That is called forward diffusion. Here is the genius part. Destruction is easy and predictable, so it can be used as a perfect teacher for creation. The training loop is almost embarrassingly simple. Show the model a clean image, corrupt it with a random amount of noise. Then ask the model one question, millions upon millions of times. Exactly what noise was just added to this picture? The model guesses, checks against the truth, adjusts, and guesses again. Slowly, it learns what noise looks like, everywhere. And learning what the noise is means learning, in reverse, what the image underneath must be. Two sides, one coin. In 2020, a method called DDPM sharpened this recipe, and modern image generators still stand on its shoulder. So the model can now recognize noise. The magic begins when you hand it noise with no image underneath at all. Generation starts with a fresh canvas of pure random static, genuinely nothing in it. No hidden picture, no secret plan. The model looks at the chaos and predicts. Here is the noise I believe is covering some image. Remove a sliver. Not all of it, a fraction of 1%. Then it looks again at the slightly cleaner canvas and predicts again. Step by step, faint structure appears. A horizon line, a mass of shadow. The ghost of a shape becoming certain. Hundreds or 1,000 small steps later, the static is gone, and a coherent, detailed image stands in its place. Why so many tiny steps? Because researchers found that many small corrections are far more reliable than one giant leap. Ask the model to jump from pure noise to finished image at once, and it fails. Ask for slivers, it succeeds. Each step even adds a pinch of fresh noise back in, a controlled shake that keeps the process from collapsing. The image that emerges was never stored anywhere. The model has no library of pictures. It has only learned the patterns. But wait, nothing so far involves words. How does typing a golden castle at sunset steer the chaos toward castle. In 2021, a model called Clip learned from 400 million images paired with their captions scraped from the internet. Clip places pictures and sentences into the same mathematical space, where a photo of a dog sits beside the words. Suddenly, language and imagery share coordinates. A caption is no longer a description. It is a location, an address, in meaning. Your prompt becomes a beacon in that space, and the denoising model consults it at every single step of the process. At each step it asks, does the emerging image move closer to the prompt's address? The text bends every decision. There is even a dial for obedience, called guidance. Turn it up, and the image follows your words more strictly. The trick behind the dial is elegant. During training, the caption is sometimes hidden, so the model learns both freedom and obedience. Turn guidance too high and images become rigid and oversaturated. Too low, and the model drifts into its own dream. One system, Imagine, even used a text encoder that had never seen a single image. Pure language was enough to steer. So, words can now shape noise into nearly anything. There was just one problem left. Doing all this took a supercomputer. A single high-resolution image holds hundreds of thousands of pixels, and most of them are, frankly, imperceptible detail. The meaning of a picture, the composition, the shapes, the light, lives in a far smaller amount of information. So in 2021, Stable Diffusion made a radical move, stopped working with pixels entirely. Compress the image first. An autoencoder squeezes each image into a compact latent code, the same picture, 1/64th of the memory. All the diffusion, the noising, the denoising, the thousand steps happens inside that tiny compressed space instead. Only at the very end does a decoder unfold the finished compact code back into a full, detailed, high-resolution image. The savings were staggering. Suddenly, image generation ran on an ordinary laptop, and millions of people could suddenly create. 64 times less memory means 64 times more experiments, more artists, more chaos, more invention. Compression democratized the dream. And compression turned out to be the key to something bigger. Because a video is just images, with one extra dimension. Remember the leap that almost broke everything? Time. 60 frames a second, each one needing to agree with the rest. Generate frames one by one and they flicker. The castle shifts, the face melts. Physics falls apart between the frames. Video needed the model to treat time itself as part of the canvas. That is exactly what the new systems did. OpenAI's Sora compresses whole videos into latent space, then slices them into space-time patches, little cubes of space and time. Each patch is like a word in a sentence, and a transformer, the same family as ChatGPT, reads them all together. Given noisy patches and your prompt, the model predicts the clean patches. Diffusion again, just diffusing across time as well. Because patches are flexible, one model handles any resolution, any length, any aspect ratio. A still image is simply a one-frame video. The result? Up to a full minute of coherent, high-fidelity video, pulled out of static that never contained it. From cream and coffee to films from noise, in under a decade, the physics of destruction became an engine of creation. So the next time an AI image appears in seconds, remember, you watched 1,000 steps of undestruction, compressed. But a machine that dreams this vividly can also dream falsely. Why AI invents facts with total confidence, next time.